Hello folks. So this is the continuation of the previous video where we were detecting and handling outliers. So previously we covered box plot, and in this video I'm going to extend the discussion with the usage of scatter plot and techniques like ZScore and interquartile range for outlier detection, which are kind of a mathematical techniques, not the visualized one. So folks, this is Nitin, who is determined to democratize the artificial intelligence, big data Hadoop and cloud computing to the world. And with this aim, I will be creating the associated content and going to publish the same periodically and made it available for you. So folks, you can subscribe to my channel to get the latest updates regarding the hottest technologies of the 21st century. So next in line for outlier detection is scatter plot. And a scatter plot is a type of a plot or mathematical diagram using Cartesian coordinates to display values for typically two variables for a set of data. The data are displayed as a collection of points, each having the value of one variable determining the position on the horizontal axis and the value of the other variable determining the position on the vertical axis. So we will try and draw scatter plots for two variables from our housing data sets. So let me open the Jupyter notebook first. Alright, so let me create few cells here first. So let's make a copy outlier. Let me make a note of it. Outlier detection part 2. Okay, so alright, so let me make a copy of the original data set so that in case of any issues we would be able to recover our data set. Okay, so Boston C is the name of a new data frame and Boston is the old original one, so we have created a new one out of the old one. Okay, and we will perform all the operations on this particular data set going forward. Okay, and this has been executed. So first thing we need to do is we will create the reference of figures. Okay, so what we need to essentially do is let me show you first. So figure AX equals, so then we will create the size of the frame here. So size of the, or kind of a dimensions of a diagram, right? So we will say plt dot subplot. Okay, and then the figure size, so fig size parameter we will give as 16 by 8. So this is a dimension of a frame where the visualization would be shown. So 16 by 8 dimension, okay, of the diagram. So this is the dimension. Then we will, so essentially what I want to tell you is that fig and AX is a short and concise way to get a reference to both figure and axis in a single step. Okay, and now what we will do is we will create the scatter plot for two of the columns. One first column is index and second one is tax. Okay, so these are the two columns on the basis of which we will create this scatter plot. So let's create it. So AX dot scatter plot, in fact scatter, so the two columns Boston underscore C, and then the index column, this is the first column, and then the next one is text, which is Boston underscore C, and the index of the column text, which is 9. Okay, okay, there is a typo, little bit typo here, AX. And now what we will do is we will set the X label and Y label in order to give more clarity. Okay, so we will give the X label and Y label values here. So AX dot set, so in order to set the X label what we'll do is we'll use the parameter as set x label. Okay, so set x label, and here we'll provide the value of the index. And similarly we'll do it for y label, just set underscore y label, which is this column tags. Okay, all right. So once this is done, the next line of code is to show this particular scatter plot. And in order to show the scatter plot, we will use a command like plt.show. Okay, and let's run this cell. All right, so looks like some issue here. Unknown property fixed size. Okay, let me check that. Again, a typo here. Subplots, it should be subplots. Let's run this cell once again. And now here you can see a scatter plot created. So you can see that a lot of points are concentrated in this particular area, right? The area below 15 and 500, right? So a lot of points are concentrated here. And from this plot we can see that most of the data points are lying to the bottom left side, right? But there are points which are far from the population, like top right corner. Okay, so top right corner is this one, this point, right? Maybe we can consider this point as well. So we can say that those top right corner points are outliers. So this is the way we find the outliers using scatter plots, right? So this is another way. We saw that these are kind of outliers here, right? So previously we discussed that these were couple of graphical ways to show outliers, but there are some mathematical ways as well to detect outliers, and one of such way is Z-score. But you might question, like, what is a Z-score? So basically a Z-score is a numerical measurement used in statistics of a values relationship to mean, that is average of a group of values, measured in terms of standard deviations from the mean. So if, let us say, there is a Z-score of 0, it indicates that the data points score is identical to the mean score. Z-score of 1 would indicate a value that is one standard deviation from the mean. Okay, and Z-scores may be positive, negative, it can be anything. But with a positive value, it indicates that the score is above the mean, and negative score indicates that it is below the mean. So when computing the Z-score for each sample on dataset, a threshold must be specified. And some good thumb rule threshold can be 2.5, 3, 3.5 or more, standard deviation. So those are some of the threshold values. Now Z-score is represented by a specific formula, as you can see above. Z equals to x minus mu divided by sigma. Okay, so this is the formula for Z-score. And by tagging or removing the data points that lay beyond a given threshold, we are classifying data into outliers and not outliers. So while calculating Z-score, we can rescale and center the data and look for basically data points which are too far from 0. Okay, so these data points which are way too far from 0 will be treated as outliers. And in most of the cases, a threshold of 3 or -3 is used. That is, If the z-score value is greater than or less than 3 or minus 3 respectively, that data point will be identified as outlier. So we will use z-score function defined in SciPy library to detect the outliers. So we will be making use of SciPy library for this z-score calculation. So let's create few cells here first. Okay. All right. So we will create. We will import the library for SciPy. Okay. SciPy library basically we will import. So from SciPy import stats. Okay. So this is the stats library which we are going to use from SciPy. Okay, and after that what we are going to do is we will also in fact not required, so I think this is the only library which can be used. Okay, NumPy we have already declared earlier, so that is anyway a standard library which we always use for any mathematical operations, right? So let's calculate the z-score, which is equals to np.abs absolute stats dot z-score and Boston C, which is our data set. Okay, so let's run this command. Okay, and if you want we can in fact let's do one thing, let's print the value. So print z-score. So here are some of the z-score values. Okay, so from these values it is very difficult to say which data point is an outliers. Okay, so that is the whole reason we always define a threshold. Okay, so let's try and define a threshold to identify an outlier, because any data point above that threshold will be treated as outlier. So in this case I will be referring the value of 3 as threshold. Okay, so let me threshold equals to 3. So I will be defining the threshold value as 3. Okay, now the next point I would like to highlight is, so as I told you earlier, any value, any z-score value which is greater than 3 is going to be treated as outlier. Okay, so let's print the values which are having the z-score value as or z-score value greater than 3. Okay, so print okay and p dot where z-score greater than 3. Here you can see that there are certain values. Okay, but don't be confused by these results, because there are basically a couple of arrays which are depicting in a combined with depicting the outlier value. So the first array contains the list of row numbers. Okay, so basically these are the row numbers and these are the column values. So second array array is the column numbers. Okay, so if we want to see the outlier value for a specific row and column combination, we can see that. And let me see, so here you can see that the row values are given here and column values are here. So let's see the value, outlier value at 100 to 102th row and 11th column. Okay, so the way we do it is, so print z-score, okay, and then 102 row and 11th column. So let's print the value, and here you can see that the value is 3.1344 and so on. Okay, so this is the outlier value. Fine. So we can see that the data point at 100 second record and on column B is an outlier. Then there is another method, which is the second method, mathematical method, to find out the outlier is calculating the interquartile range score. So box plot use this interquartile range. As I told you earlier, there was a 25th percentile and then there was a 75th percentile, right? So box plot also uses the IQR or interquartile range method to display data and outliers. But in order to in order to get a list of identified outliers, you will need to use mathematical formula, just like here I'm going to use, and retrieve the outlier data correspondingly. Okay. So interquartile range, also called as the mid spread or middle 50% or technically H spread, is a measure of statistical dispersion and being equal to difference between 75th and 25th percentiles or between upper and lower quartile. So IQR or interquartile range is given by formula Q3 minus Q1, where Q3 is 75th percentile and Q1 is 25th. So in other words, IQR is the first quartile subtracted from third quartile, and these quartiles can be clearly seen on a box plot on the data, which I have already shown you earlier. So it is kind of a measure of dispersion similar to standard deviation or variance, but it is much more robust against outlier, right? So let's do one thing first. We will create a copy of our original data set once again. So Boston underscore IQR equals Boston, and now we will basically calculate the interquartile range. Okay, so the way we calculate the interquartile range is, first of all, we will calculate the first quartile, which is given by, that is a Q1 equals to Boston underscore IQR dot quantile 0.25, and then here we will give Q3 0.75, and then IQR interquartile range equals to Q3 minus Q1, and let's print IQR. Alright, so here you can see these are some of the values associated with IQR for each and every column. So these are the IQR values of each and every column. And since we have IQR scores, now we will find the outliers now. So we'll write the code for the same. So let's create few cells first for the sake of brevity. Okay, so let's print. So we will create we will basically write the entire equation here. So Boston underscore IQR is less than Q1 minus 1.5 into IQR. This is the formula basically. Okay, and then we will copy this equation, or is greater than IQR. This data is greater than Q3 plus 1.5 IQR. Looks like some issue here. Okay, looks like I missed something here. In fact, the brackets, there's some issue with the brackets. Yeah, now it is perfectly fine. So if we scroll down and see the values, you can see there are boolean values, false and true, right? So can we see true value for any column? Yes, we can see here. So for a couple of the columns, so 18th row, and this is the column. So basically, which column is this? The index value is 11th. Okay, so basically 18th row and column 11th, or I would say yeah, 11th only, we have an outlier represented by value true. Okay, and column 11 was this one. So 0 1, no, if I start indexing from zeros, then this will be the one. So B, column B. Okay, so for 18th row and column B, we have an outlier represented by value true. So this is the way we find the outlier using interquartile range values. Okay, and yeah, so this is pretty much about it, and we generally covered two visualization techniques and two mathematical techniques to detect the outlier. Okay, so folks, this is it for this video, and in order to conclude, I can say that we learned about another visual form of outlier detection, that is usage of scatter plot in this particular video to detect the outliers. We have also learned about some mathematical form of outlier detection as well, that is using the Z-scores and interquartile range for outlier detection. So I will be covering the part 3 and the final part of this topic in the next video, which is to cover various methods for removing the outliers and imputing it with new values, or kind of correcting with the new values. So here is today's question. Do you mostly use visualization techniques to detect outliers, or your preferred option is mathematical way like Z-score or interquartile range? Please comment on the comment section given below. We would definitely like to hear from you. And if you're watching this video and you're not already a subscriber to our channel, then consider clicking that little subscribe button. And in case you have already subscribed, then click on bell icon to receive the notification whenever I will release the new video. So thank you folks, thanks for hanging out with us, and I will be covering next topic in the upcoming videos. So keep on watching. Thank you.